so we are on 6.4, which is factoring and solving polynomial equations. Okay, we are not going to do the entire lesson today. Find out how to make it stop without leaving the remote over there. So, we've already done some factoring, right? Okay, and you remember how I showed you how to factor by grouping? Okay, the main reason I taught you that right away is because now we're really going to use that. Okay, so I didn't want to waste time learning a different way when we didn't have to. Okay, so we're going to continue to use that. So that'll be the nice thing about today's stuff is you already know how to factor by grouping. Or you should know how to factor by grouping. I know it's been a long break. So that was part of the reason for the review yesterday. Now we also have and have worked with difference of two squares, right? You guys remember difference of two squares? There was some of that on your assignment yesterday. Is this a difference of two squares? Yes. Mixed, what would this factor to? And x plus 2. Okay, now the main thing you need to do, if you notice this is a difference of two squares, you need to figure out what your a is and what your b is. Okay, so you need to square root this, and that's your a. So your a is going to equal x, right? The square root of x squared is x. What's the square root of 4? So what's b? 2. Okay, and that's where you get x minus 2 and x plus 2. Okay, ring a bell? We did some of that yesterday. Okay, you also had, actually I know you had one yesterday that looked something like this maybe. Is that a difference of two squares? Is 9 a perfect square? Is x squared a perfect square? Yeah, so that means that whole thing's a perfect square, right? Difference, since we're subtracting, is 1 a perfect square? Yes. Because what times itself equals 1? 1. So in this case, what is my a? 3x, because you square root that whole thing. And what is my b? 1. So Jack, what does this factor to then? Good. And that would be your factors there. Today, we're going to take that one step further, and we're going to have the difference of two cubes and the sum of two cubes. Okay, so instead of squares, we're going to bump that a little bit further into perfect cubes. Okay, we know our different squares, right? Difference of two squares. Okay, what is a perfect square? What does that mean? Be a perfect square. What's that? Yeah, like 4 is a perfect square. That means something times itself equals that number, right? So 4 is a perfect square. What else? 9, 16, 25, 36, 49, 64, and so on, right? Okay. What are perfect cubes? 3 numbers. So it's 2 times 2 times 2, which is 8. 3 times 3 times 3, which is 27. 4 times 4 times 4, which is 64. Okay, and you're probably not going to get too big with these ones, right? Like with your with your perfect squares, we could go for quite a while, right? Well, the bigger numbers you get with perfect cubes, you're going to start getting huge numbers, right? An easy one would be 1,000, which would be 10 times 10 times 10. Okay? I mean, your 8 times 8 times 8 is a little bit more difficult. Your 7 is difficult. Your 6 is a little difficult. Your 5 is what? 125. That one should be pretty easy. Okay, but those are the things we're going to look at. So, we do have our special factor pattern of your sum of two cubes. And I am going to expect you to be able to remember this, just like I expected you to be able to remember the difference of two cubes, or two squares. Is there such thing as a sum of two squares? Did we ever learn anything like that? No. There's no such thing as a sum of two squares. There is a sum of two cubes, though. Okay? Your sum of two cubes, if you have a cubed plus b cubed, this is going to factor into a plus b times, I got that right? Yep. Times a squared minus ab plus b squared. I'll do an example here in a second, but it will always factor into that. So do you still need to figure out what your A and your B is? Yes, probably more so here even than with your difference of two squares, because you got to plug it in a lot of places. Okay, so that's the first thing I would always do, is make sure you know what your A is and what your B is. So, let's go ahead and do an example here. They gave us x cubed plus 8. Now, are these going to be a little bit harder to recognize maybe even than a difference of two squares? Yeah, because we don't know our perfect cubes as well as we do our perfect squares. Okay, is x cubed a perfect cube? Yes, because it's x to the third power. Okay, what about 8? Okay, so Kobe, what is my A? What's the cube root of this? X. And then Kobe, what is my B? 2. So now, as long as we can have this memorized, I can just plug these straight in, right? And obviously on your homework and stuff, you can write this down and you can look it up. Okay, but for test time, I'm going to expect you to know that. Okay, well my A is x, so I should have x plus 2. And then I should have x squared minus 2x four, right? These two? 2 squared 4. Okay, got you. Okay. So there I factored my sum of two cubes. Okay, now you have to be careful here. Okay, this whole section is about factoring, but there's more. And actually, it's, nope, not 6.5. Okay, this is it. So a lot of times you're going to get to this, and this is going to be factorable. Okay, it's pretty common to factor it one time and think you're done. Okay. Now, once you think you're done, there's probably going to be one more step for you to go. Okay, so let's double check this. Is there anything that multiplies to 4 and adds to negative 2? What do we think? Not in this case, right? Okay, but you need to check that every single time, because I know for a fact you will run into that on your homework. Okay? Now, is there any easy way to memorize this? Anybody see one? Let's do the difference of two cubes and see if we can find a pattern, okay? So, everybody have this down? Okay, let's go to the difference of two cubes. Your difference of two cubes would be if you had a cubed minus b cubed. Right? Because difference means subtract. In this case, you would have a minus b times a squared plus ab plus b squared. I have 8x cubed minus 27. Is that a perfect, or is that a difference of 2 cubes? Yes, because each of these is a perfect cube, right? And this is a perfect cube. Okay, so Lorelai, what is my A here? Careful. Yeah, I agree with the x part. I don't agree with the 8 part. You got to cube root that also. So it's 2. Yep. So your A is actually 2x. Does that make sense? Cube root both of those numbers. And my B, Devin, is what? It's a cube root of 27. What times itself is 27? 3. And then I just plug in, right? Okay, so then I have 2x minus 3 times, what is 2x squared? 4x squared, good. Plus a times b, 6x, plus b squared. Now I still need to check what? Check and see if this is factorable. Now, since this is not a 1, I need to multiply it with what? 9. Is there anything, 4 times 9 is? Anything that multiplies to 36 adds to 6. Well, 6 and 6, but that adds to 0, right? Or 12. 12 and 3, but that only give you 9, or 15. 18 and 3 gives you 48. Okay, so there's nothing, right? Okay, so you're done in this case. But you need to check that, because you will run across those where that happens. Okay, so now let's take a look at these. When I do the sum, what do you notice about the first factor? It's plus. So if this is plus, that's plus. If this is minus, that's minus. Okay? These are the only two signs that ever change in each one, right? Okay? If it's plus, your plus goes first, your minus goes second. If it's minus, your minus goes first, your plus goes second. Okay? That's just one small thing that helped me remember it faster. Okay. Alright, I don't know if you'll be able to follow along in the book very well with their examples. I think they're kind of confusing on how they set it up. I can't figure out how they're setting stuff up. But let's go ahead and do those same examples that they did there. Actually, let's just do... Let's do one of them. Let's do their 16u to the 5th minus 250u squared. Now, looking at this, is this, first of all, it's a difference, right? So it's obviously not the sum of two cubes. But is that a difference of two cubes? Can it be a difference of two cubes if that's a u to the fifth and that's a u squared? No. But looking at this, each one of these has at least a u squared, right? So should I be able to factor a u squared out? You guys get what I'm saying? That has a u squared, right? And that does too. It's got a u to the third and a u squared. Okay, so let's take that u squared out. And then I have 16 u to the third minus 250. Is this a difference of two cubes? Is 16 a perfect cube? No, I would always check your smallest number. Now, you got to ask yourself, can I make 16 into a perfect cube? By doing what? I would go the other way. You could multiply, but if you divide, that's a little bit easier, right? Because then you're going to make your number smaller. What could I divide by? Then you got to check, can I do that to that? Yeah, so what do I want to factor out of here? A 2. So I actually have 2u squared, which gives me 8u cubed minus 125. Now, we already talked about 8 and 125 today with perfect cubes. Yeah. Do I have a difference of two cubes now? Yes. Okay. Do I still need this out in front? Yeah, that doesn't just disappear. Some of us have had a problem with that in the past. That kind of just disappears. Okay, we can't just lose that. That 2u squared needs to stay out in front. Alex, what is my a? Okay, what do I need to do with it though? Not square root it, but somebody help her out so she can get the right answer. Cube root it. So what's the cube root of 8? What times itself 3 times equals 8? Yeah, you can. 1 times 1 times 1 is 1, right? Yeah. 2 times 2 times 2 is 8. So what's the cube root of 8? If 2 times 2 times 2.
How to get 8.
Yeah. I need to do this. This is what I'm trying to do. I'm trying to do the cube root of 8. So what times itself 3 times gives me 8. So my a is 2. Because 2 times 2 times 2 is 8. But it's not just 2, it's 2u. Because the cube root of u cubed is u. Okay? Ask him, what is my b? 5. Because 5 times 5 times 5, it gives me 125. When you're doing those, does that minus sign mean anything to you? When you're just finding your a and your b, does your minus sign mean anything? No, but now it does when we try to plug it in, right? Okay, so when I plug this in, I need a minus b because it's minus, so I have 2u minus 5 times 4u squared. Okay, we're just plugging into our equation that we have. Plus or minus? Plus 10u because it's ab plus 25 because it's b squared. It doesn't. Okay, so yeah, double check that. 4 times 25 is 100. Anything that multiplies to 100 and adds to 10. And there isn't. So you're done here. Okay? Could you do the same problem, but with a sum of two cubes? Could I change that and put a plus in there and do the same thing? Yeah. What's the only things that would change? That and that, right? Otherwise, it's going to be exactly the same. You guys want to do one more of those? Let's do one more of those. Let's do a sum of two cubes. I think the second part of today's lesson will be pretty easy for you. I don't think we need to do a lot of those. We're doing part of it, but there's still two parts. We're going to do the factor by grouping still, because we kind of already know how to do that. Okay, 64a squared plus, this one's not in your book, 27a. Oh, excuse me, that's a to the fourth. Okay, as is this is, obviously it's not a difference, but is it a sum of two cubes? Reason? Because it's to the fourth power. Okay, so we want to change this. What can I take out of both of those? An a. So I take out my a, I'm left with 64a cubed plus 27. You have to decide, is 64 a perfect cube? Yes, it is. And I know a cubed is 27. Yes, so this is a what? Sum of two cubes. Good. So I'm going to keep my a. What does a equal, Colton? So 4a, and then Colton, go ahead and give us b. 3. And then when I plug this back in, Logan, I get what? Plus? Plus what? No, we just leave this. So we're just, this first part is a plus b. So it's 4a plus 3. Okay, notice he put a plus there because this was a plus. Okay, and then it's a squared, which is 16 what? A squared. Is this one a plus or a minus now? Minus AB, which is 12a, plus 9. Now that one's a little bit harder to check, right? It doesn't. I'm just going to tell you for sake of time, it doesn't actually. So you don't waste your time. So we can keep rolling. Okay, once you know that it is a sum or difference of two cubes, once you know that, okay, and once you figured out which one to use, from there it should be pretty simple, right? Because from there you just plug it into an equation that you're given. Now do remember, you do need to memorize those equations, but I think some of us are already catching on to those. Okay? Now the other thing we need to talk about is factor by grouping. Okay, but again, the nice thing, and I think theirs is a little confusing, the nice thing is we already know how to do this. Okay? So we have x cubed minus 2x squared minus 9x plus 18. Now the difference here is in the past, we've had to make it into a factor by grouping, right? here, they already have 4 things here for us. So, all you need to do is group. You already got your 4 things. Okay, you need to group. What can I take out of these? An x squared. So I take out my x squared. Here I'm left with x minus 2. Okay, now you got to be careful. This had better be what? X minus 2. And sometimes you won't get that. You might have to go back and group different things. Okay, so I need to take out a what? Negative 9, which gives me x minus 2. You might have to go back and rearrange sometimes depending on what order they wrote it in, and maybe that x cubed needs to go with that negative 9x. Okay, you'll know though, because you'll get to this point and this won't come out to be the same. Okay, if those are ever not the same, that's a problem. Okay? So, for those of us who don't remember, what do we do now? Okay, this x squared and this minus 9 go together. And then my x minus 2's combine into 1. Now, can anybody explain to me, I told you it's been a while though, why? Why does that work? Now, I'm taking x squared times x minus 2, right? Like Kate just said, if I FOIL, wouldn't I still take that x squared times both of those? Okay, and I'm taking the negative 9 times both of those. And now when I FOIL, aren't I still taking the negative 9 times both of those? Yeah. Okay, I'm just writing it down a little bit smaller. Now, does anybody notice anything about this? Am I done? I'm not. Why, Spencer? That's a difference of 2 squares right there. Okay, that's a perfect example. We're used to factoring one time and being done. Okay, so it's going to be a change here. A lot of times when you think you're done, you need to go one step further. Okay, so always check and try to go one step further. What does x squared minus 9 factor to? X plus 3, x minus 3, and then on the end I have x minus 2. Okay, double check. Good, good, good. And I can't go any further. Okay, but you guys see how that would get confusing because in the past we've got here and we're done. Right there. Okay, you need to check and try to go one step further for me. Okay, I'm going to do one more factor by grouping with you, and then I'll let you guys get started on your assignment because I don't think the factor by grouping should be an issue. Okay, so I have x squared y squared minus 3x squared minus 4y squared plus 12. There's something we've never really seen before. Okay, so let's go ahead and group this. Okay, what can I take out of both of these? X squared. Anything else? No. So I take out my x squared, and once I do that, Devin, what do I get? Y squared minus 3. Okay. Isaiah, is there anything that I can take out of this to give me the same thing? What do I want to take out of this to get the same thing? The negative 4, good. If I take out just the 4, then I have a negative y squared plus 3, right? And we don't want that. So Isaiah told us to take out a negative 4, and I get y squared minus 3. Okay, that's good, right? Okay, so Devin, now what? Okay? Okay, so those go to 1. And go to 1, right? Okay. I have been seeing some of you before break were doing this. Well, there's 2 of them. Okay, remember we just went over they combine to 1, right? If we combine these 2 into 1, these 2 have to go to the same thing as well. And it's not squared, no. I'm done, right, Colton? Why? Careful. Difference of 2 squares. So it factors to what, Colton? And then we took care of this. What's left? Is that a difference of 2 squares? No. That's a square, perfect square, but that one isn't. So you can't factor this one any further. So you just have y squared minus 3. Okay. Questions on any of that? I don't think the grouping part is going to be the difficult part. It's going to be identifying the sum or difference of 2 cubes. Alright, what I want you to do for Monday is on page 349, 33 through 49. Some of those aren't going to take you very long.